Okay, thioesters and acid derivatives. So show the difference between an ester and a thioester. So here's our ester. I'm just taking one at random. And then the thioester is the removal of that one oxygen to create replacing it with a sulfur. So we've seen that before with thioethers, but in this case we don't replace both oxygens, we just replace the one that's in the center there. Draw an acid chloride, so we start out with a carboxylic acid, but instead of ending with the OH, we end up with a chloride. And not too much, and it says, since it says to draw one, might as well draw one that's not a general form, so that would be one. And it says draw an acid anhydride. So the general form here is a pretty large molecule, but that's a general form where you have that C double bonded to O connected by an oxygen to another C double bonded to O. So we could have something like this. If you were asked to give a real example rather than just a general form. The acyl group is this part. Now because this part can be latched onto lots of different things to create other functional groups, like that acyl chloride that we saw, and or acid chloride, I should say. So we have this group is the acyl group. And then it says draw a phosphate ester. This is important because we're going to see this a lot in biochemistry. Now this is phosphoric acid, and if we remove, and so we have that a P bonded to double bonded to oxygen, so that's like our carbonyl group. And if we remove one of the hydrogens and replace it with a say with a methyl group, to give a particular example, this would be a monoester. You can see we have two other hydrogens here, so we could keep going. We could put an ethyl group on the other side. So this is just, could be anything, just pick these at random. So this is our diester. And I don't know if they want us to go, they go all the way to the yeah, they do. Okay, so if we kept going, we could put another methyl group on the bottom, just picking methyl so it can write it easy. And this would be a triester. So it seems like a really complex molecule to work with, but we're going to definitely see it and be using it in biochemistry. So we should at least have seen it before we get there.